morning, team. So in this video, we are going to discuss about design thinking based exploration of encoder, decoder, and parity circuits. Encoder, decoder, and parity circuit has been playing a vital role in digital electronics because in nowadays we are using a lot of digital circuits in our daily life, especially for encoders and decoders. So encoder is multiple number of inputs has been converted into binary signals, and the decoder is it can be used to transfer the digital signals into the original forms. And the parity checkers is going to check the errors of the concerned bit so that we can get the original bit without any deviations. Let me see how these cycles has been applied, and it will be effectively communicated through design thinking, empathy, define, ideate, and prototyping testing stages.
Okay, we discuss about the exploration. Mainly, the main goal is to understand why these circuits are used in real-world systems. Mainly, the encoders are used in keyboards, used to convert the key digits into binary transmission. And the robotics is used in the sensor directing systems. The decoders, it is mainly used in the binary code transmissions like octal to decimal, decimal to octal.
So these converters have been used for a lot of binary systems.
And then parity cycles, it is mainly used in communication systems like UAV, IoT, and to clear all the types of errors like machine language errors and human errors, all these of errors.
So by using parity bits, we can able to check the errors in odd and even numbers.
So, in different part, we can discuss about the main core problems in many. From that, we can infer that we can need to design a circuit that has minimum number of inputs and also that encodes the decodes efficiently with a free error-free transmission. So, in this, we can use some type of logic gates. It's like in that, first of all, we split up the problem into three parts. First of all, how to that encodes efficiently and decodes from the binary data to the actual value and the error-free transmission with the help
So
of
based on the number of bits, 3 bit or 4 bit, based on the user's list, we can able to create a logic list.
Yes, sir. Based on the using that 2 bits and 3 bits, we can create, sir. In this, first of all, we need to take the minimum number of inputs, sir. So like that, as we once we discussed in that empathize part, when a special character like alphabets, first of all given in a keyboard, only a single input line is used to convert the data to binary, and from that we can convert it from the binary to the actual value with the help of the decoder. So in nowadays technologies are like Tesla's auto driving cars, they're using a many number of encoding to their decoders. So with a very small amount of time, they are using a many number of input lines. So in this, we can use this party checkers to verify it.
So parity checkers are used to check the number of transmission errors.
Yes, the number of transmission errors can be verified in this also 5G
So if it
technology.
is right, then it can be passed, or else it has to check and we need to modify the number of bits.
So next we are going to see about IDEA. So for this we have several solutions. Student can develop two table K-map minimization and pooling equations.
Because we are using different number of gates, so we need of K-map, we need to verify the expressions so that we can get the reduced number of binary expressions.
For encoder, decoder and parity checkers. So there are different design parts which are 2 is to 4 and 4 is to 16 decoders and 8 is to 3 and 4 is to 2 encoders and even an odd parity checkers. So next we need to encourage the group discussions where each team proposes how
Because
they
the
integrate.
user has to be defined that which number we have to generate.
Yes, sir.
Because there are a lot of 2 power 16 or up to 2 power 16 we have to generate. So the user has to be defined which kind of information we need to pass.
Yes, sir. And we need to encourage the group discussions where each team proposes how to integrate the encoder to design a digital signal, and also we need to use decoder for error reduction.
This prototype. Prototype where our ideas move from paper to real world working model. For instead of just talking about encoders, decoders, or architectures, we actually build them. First, we try simulation tools logarithm or proteus to draw a circuit and check if the output matches the truth table. This is safe, quick. And next we move to hardware. For example, we use
Moreover, we
ICs
are using
like
fine Minkowski method also there for checking the number of bits for prime numbers.
For example, ICs like 74LS147 for encoders and 74LS138 for decoders and XOR gates for package checkers. By connecting them, we can get with LEDs or displays.
So we are using model sim also for running to get the output of the runs input signals.
Maximum keyboard is a best example where encoders, by pressing the key on keyboards, decoders drives a 7-segment display and checks
Digital
the
logic signals.
it checks how many signal has on wire.
So
And the next is
first,
this use first we have to check the encoder, decoder, and package checker circuits are and implement it if they need it. So first we have to check. First we have to give the valid input to the encoder and see the outputs are corrected or not. And the inputs are passed to the decoder signals because we need to check the decoder outputs also.
we need to verify the bits through the package checkers. So if it is having a odd number, then we need to check the number of ones which is generated on the input signals. So based on the errors, we need to rectify and we can able to transfer that.
We need to implement the error because the package checker are working on it. So by that we given an error, the package checker are worked the
Check the errors based on the number of ones generation during the transmissions.
So I'd like to conclude by saying that by using design thinking, we will be able to learn not only about the decoder, encoder, and balance checker as a theoretical way, but also as a practical and experimental knowledge for us in order to develop in IoT based and embedded based systems. So which enhances to get more deeper industry based knowledge in manufacturing of robotics and digital systems.
VLSI
communication.
system. So we can conclude that it is not only used for digital, we are using a lot of application as Intel processor and NVIDIA processors. Nowadays they are using a lot of digital gates for making their processor. So I hope we are using this processor in future as a huge number of applications. Thank you.
Nice.